Hello, I'm Dr. Taylor, and welcome to Dr. Taylor's Pedagogical Notes for teachers and for students. So, what we're going to look at next is whole number division. This is the fourth presentation. So we've done all of the whole number basic arithmetic procedures now when we finish this one. Okay? So, without any further ado, let's get going. Like all of the presentations, the first slide tells you we'll be going from concrete to abstract. There'll be links for the post-activity student accountability worksheet for the printable that you can run off. They can do in pencil and paper, or the electronic, which they can do on their computer, smartphone, what have you, as long as it has the ability to modify Google Slides. All right? So let's get going. And we're looking at 78 divided by 3. Okay? So we're going to ask, how many is 78 divided by 3? Not what is. How many? Because we're talking about things. When I say what is 78 divided by 3, it's a problem. it's a mathematical problem that's naked. It has no context, and so it's just an exercise in futility, because without context, numbers are useless. What am I enumerating if there's nothing there? And what do I care about how those numbers relate to one another if they're not representing anything in reality? I don't. And that's why most kids don't care what you're doing, because it doesn't relate to anything in reality for them. So let's make that happen. Let's give them that relationship piece so they can start to build upon those relational realities and make their schemata grow. Okay? So here we are going to decompose our 78. What that means is I'm going to break it apart, right? I'm going to take it apart, and I'm going to take it apart in an easy way. I'm going to take the 8 off the 70, because 70 is a nice round number. You know, it has that 0 in the end, and we have maybe learned some divisibility rules, or maybe we haven't gotten there yet, but I can skip count by tens probably pretty easily, right? That's one that people get pretty well, even when they struggle with math. They can count by ones, they can count by tens because they just stick a 0 on the end of their number, okay? So let's decompose. So 78 is 10 and 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 8, okay? So here we can see, how many tens do we have? That's right, we have 7, okay? And now down here, the 3, it's still 1 and 1 and 1, and we're gonna deal with that in a second. But it's no longer like it was for multiplication or addition or subtraction. That 3 is called the divisor, and so it isn't used in quite the same way as it is for the other 3 processes. The division piece is a little bit more, not how many is or how many more per se, as much as how many goes with each unit of the 3, right? So if I partition my whole things into 3 piles, how many is in each pile? That's really what we're asking when we divide. If I break it up into even piles, how many is in each pile? And until you play with that division process with students, they're not really going to master that algorithm well, because they're not going to understand what it is. But if you, or even better than that, reducing a fraction, right? Looking at a ratio and simplifying it. Without this understanding, it's just an exercise, and I hope I got that right, and waiting for the teacher to tell me so. Instead of knowing, and I don't have to wait, I don't even have to get, confirmation, because I know, right? And if I don't know, the students in my little table set, they'll know, and we can know together. And that builds consensus, and consensus builds knowledge. I can't tell knowledge. I can't tell knowledge. If you're telling from the front of the room, you're not transferring knowledge, okay? All right, so let's decompose the 70 into sum of tens, which we did, okay? And then the 8, we're going to decompose it into a sum of ones, because it's not a 10, right? And it doesn't, what good is it to divide it into 5s or whatever? And since these are ones, I figured, why not put those into ones? What's the worst case scenario? Maybe I would like it in 2s, and I would group them together, etc. But we're going to stick with it. So now we've decomposed everything into sum of units. Whether we needed to or not, it's done. And now we shall place a base 10 rods, okay? So in other words, if I were using a square, it would be 1 by 1. So a 10 would be 1 by 10, right? And so I'm going to use Cuisenaire rods this time instead of colored squares, just to mix it up a bit, okay? So this is 10, imagine 10 little cubes squished together, right? That's what a Cuisenaire rod basically is. Of course, it's not just tens, right? But this one is a tens rod. How many 10s do I need? Well, that's the first one. I need the second one. I need the third one, and the fourth one, and the fifth one, and the sixth one, and the seventh one. So there are 7 Cuisenaire rods, each worth 10. What is 7 10s worth? It's worth that 70 piece that we decomposed into 10s, right? So if these rods, 10 units long by 1 unit wide and high, is a 10, what do you think a cube's dimension will be? Right? Yeah, it's going to be 1 by 1 by 1, because it's a unit. If any of its dimensions is more or less than 1, it's no longer representing a unit. A unit is A1 in whatever way you define it. It could be 1 car, which is built of a lot of things. It could be 1 bolt, right? In this case, it's 1 cube. All right? So there's my 70, and you can see that now, okay? Next, I'm going to unit blocks for 1s, but those are little cubes. How many do I need? Well, there's 1, 2, 3, 4, 5, 6, 7, 8. And notice how I group them. I group them conveniently for myself. Okay? I group them conveniently. Did I group them conveniently to divide by 3? Maybe not, but I grouped them in little pairs, and to me, that looked convenient. Could I change my mind? Absolutely. So don't get all caught up in it. Just start and then adjust. That's the secret to overcoming problems. Can't know what to do. You can only speculate and begin and then change your mind, but not quit. All right, so now I have 78. Everybody see that? I hope you can. Now I'm going to look at how many containers. How many containers am I going to distribute my 78 into evenly? Well, how many containers is it? It is 3. So let's have 3 containers. Okay? And now what I'm going to do is just this simple. You've got the Cuisenaire rods. You're going to take them and put them into the cup, right? If you do them one at a time and you go sequentially through the cups until you can't do it evenly anymore, it will make sense to you. You begin to understand what partitioning a number is, and how division is just partitioning a number into groups that have equal values. Okay? And some numbers don't partition evenly, right? Depending on how you're partitioning them. 4 doesn't partition nicely by 3, but it works great by 2. Yeah? So we've got to be cognizant of that, and we can explore and figure out whether something works or not. If there's a remainder, we can attack that down the road. All right, so let's start. Let's go ahead and put some blocks in. So I'm going to take these 2 blocks. I could do it one at a time, but I notice I have 1, 2, 3, 4, 5, 6, 7. So I can skip count by 2 and kind of be more efficient, right? So there's 2, and there's another set of 2, and there's, how many sets of 2 is that? Oh, yes, 3. And how many partitions do I have? Yes, I have 3 of them. So what that means is I'm going to go ahead and take those and put each one of them into a cup. So that one's going to go in there, that one's going to go in there, and that one's going to go in there. Does that make sense? Because I'm dividing by what? 3. That's why I have 3 containers. So let's go ahead and put them in there. So what's 2 10s worth? It's worth 20, isn't it? So that means in this cup right now is 20. And the next cup will be 20, and then that cup will be 20 more. So now our cups have all of the 10s that I could group evenly. The problem I have left now is I have 1 10. And that 1 10, I can't just stick it in any one cup, because then they won't be even. What do I have to do then to break that 10 up? How could I decompose it? That's right. I can turn it into units. And how many units are in a 10? 10 ones make a 10. Or so there's 10 units. And I will break that into 10s. But for now, let's go ahead and see what we can do with our units. We're going to break that up, thinking about it while we were done. But why did I jump here? Because I could. Now, then if there's anything left over, I'll worry about the leftover pieces and how they might break up or combine in the end. So there's a group of 2, there's a group of 2, there's a group of 2. How many groups of 2 do I have? Yes, again, 3. So what am I going to do with those groups? You guessed it. I'm going to put each one of those groups into the container. One into that one into that. Only one group per container to keep it even. So when I put those 2 into a container, I now have 22 instead of 20, don't I? And there's only 6 of them left, right? Like now there's 10 left, now there's 6, right? Well, when I take these 2, how many will be left there? You got it. And how many will be in there? Absolutely. So I take those 2, there's only 4 of them left. 2 of them went in there, it's 22. These 2 are going to go in there, making it what? Absolutely. And so now, is that an even number that I can put in 3s? No, I can't put that into 3 containers either. So now we're going to go ahead and we're going to break this 10 up into units. Okay? What is 10 and 2? Is that something I can divide by 3? Let's see. Okay. So when I take this rod and turn it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got an X over because I've converted this into ones, right? So I no longer have a long rod. I just have a bunch of little units, okay? And I can use those little units together, those cubes. So let's group those cubes all together, right? And now I have 12 of them, okay? And I'm going to go ahead and start to cluster them. There's a group of 4. Can I skip count by 4? 4 and 4 is 8. 8 and 4 is 12. Is there anything left over? No. How many groups were there? 3. So why did I choose 4? Because I had some insight. Could you have done it? Put one in, 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 put one in? Yes. Would that be bad? No. Who cares what insight you bring to the table as long as you can gain insight through the problem-solving process? That's what matters. Okay? All right, so let's put these groups in. These 4 are going to go in there, those 4 in there, those 4 in there, and that's going to become 26. Now I have 8 left. I'm going to put these 4 in there. That becomes 26, and I have 4 left. I'm going to put these 4 in there. That becomes 26. I have 0 left. That means no remainder. What does that mean? It means that 78 indeed does divide evenly into 3 parts. And when I do that, each container, each partition, each part will get 26 items. Okay? So that is our answer. 78 can divide into 3 partitions if I put 26 into each of the 3 partitions. Graphical, right? I can decompose. I can think about it that way. I can have strip diagrams. You can see that that's really the same thing as the Cuisinart rods. It's going to be the same basic scenario, right? So that is 1, 2, 3, 4, 5, 6, 7, 8 ones, right? Am I going to have 3 groups of 20? Yes. And those 2, 4, 6. There's 3 groups of 2, yes. And they're going to group up. And notice that we could have another group of 3, but I had 3, 6, and then 2 left over. That didn't work so well if I wanted to put stuff into 3 piles. I chose a smaller number to help us do that, right? So that's why we're doing what we do, okay? So I could have done it and then taken one away instead of added one on, and that's a whole other strategy, but I just wanted to touch on it's okay if that's what you're doing. There's not just one way to do this, okay? So we can see that each container got 2 longs and 2 shorts, so that's 22, and this is what's left over, the long and 2 shorts. Can I take and cut that into 3 pieces? Of course I can, right? So my 10 strip, I break it apart, and now I can group all 12 of those into 3 even piles. Each container, remember this represents each container. I didn't draw all 3 containers on here because of room. I want you to be able to read this. But what happens when I put 4 in with those? What do I get? Besides that, I get 2, 3, 4, and that is 20. 1, 2, 3, 4, 5, 6. Okay? All right. Symbolic. There's my numeral decomposition. 20, 20, 20, and 2, 2, 2, right? So what do I have there? Okay. Our leftover parts, 10 and 2, all right? Which is 12. 12 I need to decompose into 4, 4, 4, right? Now I pick one of each. Why? Because there's 3 20s, there's 3 2s, and there's 3 4s. And if I'm going to put them into 3 different containers, each container will get 1 20, 1 2, and 1 4. So 20 and 4 is 24, and 2 is 26. And again, we have a reaffirmation of what we've discovered through our other strategies. And finally, could I have done it a different way? Yes. I could do what's called repeated subtraction. Now think about this. Multiplication can be done as repeated addition. So subtraction, which is the inverse of division, which is the inverse of multiplication, can be done with repeated subtraction, which is the inverse of addition. So what undoes multiplication is division. What undoes addition is subtraction. So if repeated addition does multiplication, it follows logically that repeated subtraction does division. But let's not just trust the logical following. Let's make sure. Let's keep taking 3 away from 78 and see how many 3's will come out of it as I take it away. Okay? So I take away a 3, I get a 75. I take away another 3, I get a 72. I take away another 3, I get a 69. Another 3 is 66. Another 3 is 63. That's 5 subtractions. 1, 2, 3, 4, 5. So how many 3's have I taken out so far? 5 of them. 5 isn't an answer. 5 is how many 3's I've taken out. But am I done? Is 63 smaller than 3? No. So I can keep taking 3's out, and I will. So I'm going to keep going, all right? So 63 minus 3 is 60. 60 minus 3 is 57. 57 minus 3, 54. 54 minus 3. I think you can see it. I don't want to go too fast, because if you're a struggling student, I want you to have time to think about it, all right? And press pause and look at it. You know, you don't have to hear me to figure it out. So that's 10 of them. I did it in little groups of 5 for convenience, because it was easy for me to skip count by 5. 5, 10, 15, 20. I can count that way pretty nicely. Okay, so let's keep going. 48 minus 3. Okay, I'm going to have you try to finish. At this point, you would click the timer and try to do it. I'm not going to do that. I'm going to go on, so if you're watching this, you can continue. But realize timer's right there, and you'd use it and work. And if I keep going, I have, hopefully, gotten down to 33, 15 subtractions, and now go ahead and try the last row. Again, I would time it, let you give some time to do it. We're down to 18, still bigger than 3, right? So what am I going to do next? That's right, I'm going to keep doing what I'm doing and go ahead and finish it up. All right, and so you finished it up, and you get 18 minus 3, 15 minus 3, 12 minus 3, 9 minus 3, 6 minus 3, and 3 minus 3 equals what? 0. When it equals 0, that means it went in evenly. If it equals anything more than 3, I keep subtracting because I'm dividing by 3. If it equals anything less than 3, I'm finished because I can't take another 3 away. But if it isn't a 0, it doesn't go in evenly, and that will be my remainder piece. But since there's no remainder, how many 3's did I have? I had 1, 2, 3, 4, 5. Let's skip count. 5, 10, 15, 20, 1, 2, 3, 4, 5. Holy cow, 6, 26. We have just proven to ourselves that division is repeated subtraction. And whatever the divisor is, I can take it away again and again and again. And how many times I take it away is the answer to how many things go into a partition of 1/3. Because that's what dividing by 3 is. If I divide things by 3, each partition gets 1/3 of what the whole thing was. If we cut our pizza up into 9 pieces, we will each get 3 of them, because that's 1/3 of the pizza that we're sharing equally. It's important. These are connections that you can intellectualize and you can say and expect them to know. Look, I just told you that yesterday. Telling means nothing. Explore, explain, dialogue through the class, back and forth to students. Use the discourse model. Build the understanding, build the capacity. You will reap the rewards, and your life will get easier, and the students will be happier. All right. It means it divided evenly. I said all that. Abstract, real quick. We could avoid the algorithm, right? I can subtract. I can break it into groups in my mind, or I can do the algorithm if I know it. But avoid doing the algorithm if it hasn't been taught yet. Let them discover how division works. All right. So there it is. Thank you very much. Division takes a while. Sorry for the length of this thing. Next will be fractions. We'll start with adding rational numbers or adding fractions. See you there.